Welcome back. In this lecture, we will learn about data frame reuse and data frame caching or table caching in the Spark memory. So let's start. To help you understand the idea of data frame reuse and data caching in the Spark memory, I've set up a scenario. Scenario is available in Python and Scala. Both the notebooks are available along with your course material. But for this demo, I'll be using Python notebook. So let me go to my notebook and open it. I'll open two notebooks here. The first notebook is reusing data frame before and then reusing data frame after. So before notebook is with the problem and after notebook is after solving the problem. So let's start. Let's start with the problem statement or the scenario. So what is the scenario? I have a team. They are Spark developers. They have built a Spark job. A Spark job is running perfectly fine, no errors. But my team came back with some observations. So what they noticed and what is the problem statement they gave to me? We are creating a data frame and executing multiple queries on the same data frame. So what they are doing, they are creating a data frame maybe using a spark.read operation. And once that data frame is created, they are using multiple queries on the same data frame, right? However, our queries are running slow. Simple, straightforward complaint, my queries are running slow, right? But my team is smart, they have good knowledge. So they went ahead and they did some investigation. So here is the statement. We investigated the query plans and noticed that Spark is recreating data frame for every query and reading it again from the storage. So for example, they created a data frame, let's say df1, and then they are running 5-10 queries on that same df1 data frame. But Spark is reading the data again and again and again for all the individual queries. That's what they noticed. I don't know how do they confirm that. We will confirm it again. But they did it. We investigated the query plans and noticed that Spark is creating the data frame for every query and reading it again from the storage. That's a big statement. We have the following questions. After this observation, they came back with 2-3 questions here. Spark is an in-memory computation engine, right? We all know Spark is advertised to be an in-memory computation engine. So that's correct. Once we create a data frame, it should bring data into the memory and execute all queries from the in-memory data frame. So if it is an in-memory computation engine, so once you read a data and create a data frame, the data should come and sit in the memory. And once it is in the memory, you run 10 queries on that same data frame, all should be reading from the memory, right? That is an expectation. That is how an in-memory data computation engine should work. But why Spark is reading data again for each query? Spark is not doing that. Why Spark is reading data again and again for every query? That's the doubt. That's the question. Once we know the answer, why? How can we reuse a data frame to optimize the performance of our queries? How can we implement the reuse of the same data frame instead of reading data again and again? That's the question, and we will figure out the answer for this. But before that, I will validate this statement. What they are saying is, once we create a data frame, it should bring data in the memory and execute all queries from the in-memory data frame. And what they are saying, they investigated, this is not happening, right? So we will validate. So what do we want to benchmark? To solve this problem or to start my investigation, I came up with the idea of creating a benchmark before, and then we will investigate, and whatever we figure out, observations we make, we will implement some ideas of optimization and then do the after benchmark. So this is my before benchmark notebook. What do we want to benchmark? Observe and validate the behavior of multiple reads. Whatever my team is claiming, I want to make sure that we observe that and we have a proof for this, that Spark is reading data again and again for all the queries on the same data frame. It's not reusing the data frame from the memory. We will validate that and then find a solution to reuse an in-memory data frame. That's the objective of this benchmarking activity.